Hello and welcome back. Today I'm going to show you how to program a Ubiquiti Nano Bridge. This is the standard radio of the M series that Ubiquiti makes. First thing we need to do is we need to set our IP address for our computer so that we can communicate with the default IP address that's on the radio itself. I'm going to go to my system preferences. I'm going to select my Thunderbolt. I'm going to choose manual configuration. I'm going to give myself an IP address in that range. So for instance, 192.168.1.223. It's a /24, so it's 255.255.255.0 for my subnet mask. And I'm not going to put a gateway in there for now. So go ahead and open a new tab and browse to 192.168.1.20. Hit enter. And this is the Ubiquiti Radio web GUI. The default username and password is Ubiquiti. You need to select your country, United States, and then you have to agree to their terms and conditions, then hit login. So now it shows you that I'm logged into this Nano Bridge M5. I'm currently running firmware version 5.6.1. The first thing I'm going to do is I'm going to go ahead and upload the new firmware. I'm going to dismiss this pop-up for now. Jump over to System. Right here where it says firmware version XM version 5.6.1, I'm going to be looking for the XM firmware version, the newer file. To acquire the newer file, you can go ahead and browse to ubiquiti.com. I'm actually not on the internet. Let me turn that back on. I've already got the firmware downloaded, but I'm just showing you where to get the firmware just for demonstration purposes. So once you go to Ubiquiti's website, click Downloads, and then this page appears. Go to AirMax M series down here in the bottom left-hand corner. And now our firmware is going to show up here. If you notice, we just had looked at the XM version. So this is the XM board version 5.6.8. So there's a few versions ahead now from that current version that's on the radio. So we're going to go ahead and download that. Hit download. Download it. And there it is. Okay, so now I'm going to jump back to the radio. I'm going to go ahead and choose that firmware that I just downloaded. Choose my download folder, and it's this XM version 5.6.8 bin file. Go ahead and hit open, and then hit upload. Now it's going to upload the firmware to the radio. It's going to check it. If it looks good and it seems like it's the correct version for the board, it'll go ahead and validate it, and then it'll go ahead and ask us if we want to go ahead and upgrade, and we will say yes once that pops up. Go ahead and disconnect off my Wi-Fi because I've actually got an IP conflict. My Wi-Fi is also 1.network, so now that I've downloaded the firmware, I don't need to be on the internet anymore, so I'm going to go ahead and do that again. Choose firmware, open, hit upload. Now it says uploaded firmware version XM version 5.6.8. We can discard it if we changed our mind, but we're going to go ahead and update it. And now this does take a while. You cannot power off the radio while this is happening. You could brick the radio if you do that. And you'll notice on the radio itself, you'll see a light series just kind of cycling one after another. So it'll go red, orange, green, 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 red, orange, and back and forth. and that's just indicating that the firmware is being uploaded and configured onto the radio itself. And this does take quite a while, so just be patient with it. You know, you can do your paperwork or something while you're waiting for this to upload. Almost done. Okay, it finished. So you'll see this SSL certificate error every time you go to log in to the device. It's just saying that it's, it is secure because it's using HTTPS, but it's just saying that it's, invalid. But anyway, just hit advanced. Depending on what your browser you're using, you might have to add exception, something to that nature. Just click proceed. You'll have to log back into the radio, so UBNT, hit enter. Okay, so it took the firmware. See how now it says firmware version XM version 5.6.8, so that's good. Now we'll go ahead and go through the steps for programming. So we'll start in the System tab. We'll start at System and work our way forward. So go ahead and change the device name to the client name. So for this instance, we're going to do Gloria Bush. We're going to select the time zone, Mountain Standard. We're going to enable the startup date. We'll say today. We're going to go ahead and put in the Clear Networks radio credentials, which I'm not going to say. You will know that if you're one of our installers. Okay, and then go down here to the bottom and hit change. Don't hit the test, apply, or discard or anything yet. We're going to go ahead and go through each tab before we apply this configuration. Apply will be the very last thing we do. So after you've made the changes to the System tab, go ahead and jump over to the Advanced tab. Actually, let's go ahead and go to the Services tab first. We're going to go ahead and set the NTP client to enabled. And we're going to set it to our NTP server so that everyone's on the same time. And if we're troubleshooting to catch logs, we can catch those with the correct time. So 206.123.208.23 is our local time server on our network. If you're not on our network, you can't get to that server for time. Make sure system log is enabled, which it is. Discovery protocols, yeah, all that looks good. We won't really worry about anything else in this video. Go ahead and hit change on the bottom right hand corner. Now go ahead and move on to the Advanced tab. Okay, so now this is important with how we have to regulate our radios and everything. You need to make sure you check the installer EIRP control, and I'll show you that when we get to the wireless tab, how we actually configure that. So leave the distance set to auto, don't change anything else here. Everything else is good. Go ahead and hit change. Go to network. Go ahead and change the, excuse me, everything in this tab is correct except for the configuration mode. We need to go ahead and change that to advanced. And then see how a couple things changed here. Bridged is fine, we want to keep it that way, but we're going to go ahead and change this IP address to the subnet of the tower that we're going to hook up to. For this instance, I'm going to hook up to the Sunset Mesa North Tower, which is 192.168.44 subnet, and I'm just going to give it a random IP address, 221. I believe my computer is set to 222, so I'll go ahead and give it 221. But normally you would get this IP address through IPAM, either before or through the Jetpack to get that IP address. Go ahead and scroll down to the bottom of this page, hit the plus mark for traffic shaping. We're going to enable that. Now we need to set the limits to this radio so that the customer doesn't use an unlimited amount of bandwidth. Ingress we're going to uncheck, and egress we're going to define. So the interface WLAN 0, egress, for example, this person will have 5 megabytes of upload. WLAN is upload. We're going to set it to 5240. We guys give them just a little couple extra kilobits just so that they could see more of a realistic speed when they run speed tests. Once that's entered, go ahead and hit add and see how this next line just dropped down here, and it says LAN 0, and it's already, and ingress is already unchecked. We'll go ahead and leave that, and this is where we're going to actually specify the download speed, which this client's going to get 10 megabytes of download speed, and just like the upload, we give them just a smidge extra. Go ahead and hit add, and now go ahead and hit change in the bottom right hand corner. Now go ahead and go to the wireless tab. Okay, so this unit is a station, so it's going to be in station mode. The tower, it's in access point mode, so we don't want to be in any of those other modes. We want to be in station mode. We want to enable WDS transparent bridging mode, and then if you're on site, you can go ahead and hit select here for the SSID, and it will run a scan. I'm going to go ahead and show you that now. So see how this radio brought up several SSIDs that it can see. Notice the noise is pretty horrible. That's because I'm inside the house and I'm, picking it up through the roof and everything, so the signal's not great. But for this instance, we'll go ahead and just select one, hit the little check mark, and in theory, you'll always select the best signal. And just so you're aware, this indicator, this all means something. So if it's just something random, it's probably not our equipment. If it starts with CL dash, it's our equipment. And so for example, this means Clear Networks is CL. The next octet is SMN, which stands for Sunset Mesa North. And then the next octet is NW, so that stands for Northwest. So if you are, northwest of the tower, you would most likely, want to select the sector that's pointing towards you. We're going to go ahead and hit select. We're not going to use lock to AP because if we actually lock to AP, it's going to pull this MAC address in. And the issue with that is if we ever have to replace this radio on the tower because of a faulty radio, lightning, anything, all of a sudden we can't get back to this client because it's locked. So we're not going to do that. We're going to go ahead and just hit select. And see where this lock to AP is empty? We're going to leave that empty. So see how it jumped me down here to the WPA key? Go ahead and type that in now, and you're going to know what that is, like I said, if you're one of our installers. Here's where we need to specify the antenna type. If it's a Nano Bridge 5G25, you're going to use the 25 dBi antenna. If it's a Nano Bridge 5G22, you're going to use the 22 dBi antenna. You're never going to use feed only. I'm not even sure why Ubiquiti gives you that option. I guess if you just wanted to, use the feed horn in a house on the ground or something, I don't know. But we will never use feed only. Go ahead and select that, and then this calculate EIRP limit, uncheck that, and then just make sure your slider's all the way to the right there for the output power. We can come back and dial this back once it's connected and everything looks good. So really that's it. You're going to hit change, and once we hit apply, it's going to go ahead and connect to the tower. However, you do need to be aware that not all of our sectors on the towers operate on 20 megahertz. Most of them do. I'll tell you that 90% of them do, but there are a handful that operate on 30, and there are a handful that operate on 10. So if for some reason you're on 20 megahertz and you're running scans and you don't see anything, why don't you just go ahead and jump to 30 and run a scan and see if that helps, or jump to 10 and run a scan and see if that helps. And just so you're aware, when you jump from 20 to 10 or 20 to 30, you do have to hit change and apply before you'll be able to scan and see that channel width. It's not an active change. It actually has to grab that config once it boots again. So we'll go ahead and hit change. We're going to set it to 20 megahertz because that's where we scanned at. I'll just show you again real quick there. See, there's the northwest sector to 20 megahertz. There it is there. And now we're going to go ahead and hit apply. Now it normally takes a minute or two for it to boot back up, load its new configuration. Now, if you should have taken a note of what IP address we changed it to in the network setting. Since it's going onto a management subnet, we need to go ahead and put our IP address of our computer onto that same subnet so that we can verify that it got a connection and that it's connected to the tower. So I'm going to jump back to my network settings for a second, and I know that subnet because it's a 44, so 192.168.44.223 is what I gave myself. I believe I gave the radio 221. I'll hit apply. Yeah, I gave it 221, so it's going to redirect you to the IP address that you gave it. And I'm going to just hit refresh there. I'll hit advanced, proceed, and it's going to make me log in. So this is going to be the new password that you set when you applied that configuration. Okay, so see, it brought me right back to the page I was in. I'm going to go ahead and go to the main page now, just so I can kind of see a live statistic of what is going on with the radio. So device name, it's the client name, Gloria Bush. This is her signal strength. Like I said, it was horrible. This is the transmit and receive rate. This is the radio's modulation rate. This isn't actual throughput, nor is it isolated capacity. Another thing to keep an eye on is this transmit CCQ. If that is down in the 70s, 60s, low 80s, that's pretty horrible. That's something to watch out for. If you run a speed test right now, you won't even get 1 meg across this link. It's pretty unacceptable. A realistic number to see here is something in the mid 60s. Well, it would be the mid negative 60s. Ideally, you're going to be in the 50s. Our line, we don't accept anything worse than a negative 72. So neg 72 and beyond, so neg 80, neg 90, all that, it's unacceptable. We can't service that type of a signal strength. So we would have to come up with another solution or something for that type of scenario. I'm going to draw your attention over here to the left for a second. So Gloria Bush is her radio. She is connected to SSID CL-SMN-Northwest. She's running firmware version v.6.8 XM. The security protocol that it's using to connect to the tower is WPA2, AES. The channel frequency that it's sitting on, that is dictated by the tower, and it is 5290 megahertz, or channel 58, and that's a dynamic frequency selection. So if that tower for some reason sees radar on that frequency, it will have to shut down, change channels, come back online. And when that happens, all clients go offline until they can reconnect. So that's something to watch out for when you're using DFS channels. Here's the channel width set to 20 megahertz. It shows you the frequency band, so where the channel overlaps to, each side of it. Shows you the distance to the tower, or the access point. It shows you the chains, which is, this is just the 2x2 technology, so a MIMO technology. This is the transmit power, which we're transmitting at 23 dBm. The antenna, it's 25 dBi gain. It's 400, I think they count that like 400 square centimeters or something like that. This is another thing to watch out for. This LAN 0, it needs to be, if it's a M series radio, 100 megabits is its maximum negotiation rate. So watch that. Sometimes you'll get a cable or something where it will not negotiate up to 100. It'll negotiate to 10. And if you don't notice that right away, you know, the client might have issues later on down the road. So I'm going to bring you down here for a second. This is actually showing live traffic across the link in kilobits. So as the traffic ramps up, it'll go ahead and change into megabits, but it's just, you know, basically pinging across there, just a little bit of chatter back and forth, a little bit of ARP traffic. So it's really not talking much. Okay, so at this point we're connected. We can go ahead and go back to our network settings here, and we're going to set it back to DHCP. What this is going to do is the router that's at the tower, it's going to talk through the transparent bridge that we just created from the access point on the tower to the station at the client side. And what it is just a big invisible patch cable. And by setting us to DHCP, the router on the tower is going to give us an IP address. So I'm going to hit apply. And I'm going to wait for the IP address that the tower is going to give us. So bam, there it is. 206.123.219.232. So now we are actually able to get on the internet. And notice how the radio kicked us out. It says error 403 forbidden. We would actually have to close our browser, relog into the radio to view it. This is just a security protocol that Ubiquiti's enabled in all of their radios. So I'm going to go ahead and close the browser. And I'm going to reopen it and show you that I can just get right back in. 44.221. Enter. That's going to ask me to log in again. And like I said, that connection's horrible, so it's going to be very sluggish filling. See, it's having a hard time even connecting, so I'm going to go ahead and pull my terminal window over. Close that. I'm going to go ahead and ping Google just to see if I'm dropping packets. And sure enough, so see my response times are quite high. You know, I'm not getting, oh, I got a couple 2 digits there. And then see, I dropped the first packet. And these are just 64-byte packets, so it's not much data moving across there with just pings. That's why it's important to get your signal just as good as you possibly can. See if we can refresh that, make it come up. I'll be able to, should be able to get in from the back door if I open my Wi-Fi up. Well, anyway. Normally I would be able to log back into it because there is a route from this public subnet at the tower to get back into the management subnet so that you can point the radio, fine-tune it. I'm going to go ahead and give my computer a management IP address again just so I can get back into the radio. Apply. And now, boom, there it is, because now I'm directly connected to it. It's not actually going through the radio and back. I'm actually just going straight to the radio and not past it. And then you're going to have to put in that Clear Networks password again. Yep, and it's saying forbidden because I've tried to pull it up while I was on that public IP address. So I'll close my browser, reopen it, let's try it again. There we go. Okay, yeah, it's not going to show I was going to show you our true throughput across here. Oh, see, it just disconnected from the tower. The signal's so horrible. But let me kind of show you what these little links are real quick. So you can click on AP information. Right now it's not associated. Oh, it just associated, so hit refresh. And so now it's going to show you everything to do with the access point that it's connected to. So it's going to show you the device name. It's going to show you its connection time, its received signal, the noise floor, which all of this is up here as well. But sometimes it's good to actually see. And see, these are your negotiation rates. So if you were expecting to get a lot more speed out of this device that you're wanting to, you're going to want to see a pretty good signal down here on the MCS15 because that's the negotiation protocol that the radio uses to modulate higher data rates. So see, we're modulating way down here, you know, barely anything. The MCS0 and MCS1. It's going to show you distance, CCQ. It'll show you the IP address of the tower access point that you're connected to. Go ahead and jump over to interfaces. So it's going to show you the MAC address, bytes in and out, depending on which interface. So bridge is these two interfaces connected together. That's where the IP address resides. LAN is just the interface that connects to the client's router or your computer right now. WLAN is the interface that connects to the tower. Go to your bridge table for a second. And so see this, I'm going to go ahead and sort by interface. See where this says LAN 0? So this is the MAC address of my computer that's connected to the interface LAN 0 of this radio. So when you're filling out your wireless form, it asks you for the router's MAC address. If you forgot to get it, or you're moving on, or you don't have the box, you threw it away, and you're filling out the paperwork in the kitchen, you don't want to walk over to the living room where the router's at, you can log into the radio, you can go to bridge table, you can sort by interface, go to the LAN 0, there's only going to be one. That MAC address right there is the MAC address of the router. You can copy and paste it to your wireless form. It's easier than retyping it. Routes, you just shouldn't pay much attention there. Logs may be useful for you to go through sometimes. See how the dates are all crazy up here? So this was before we put in our configuration to get our NTP server from locally on the network. Really won't use this for much other than like watching for radar. So you see it's saying it's set frequency to 5.2 or 5.29 gigahertz. But if it sees radar, it'll show up here in the log. It's very helpful for troubleshooting. But anyway, that's about it in a nutshell. If you have any questions, of course, go back to my website and just hit contact me. Just hit contact and feel free to ask me any questions. Thanks, and I hope you enjoyed this video, and we'll see you around for the next one.